Yes, class. You're welcome. Good afternoon. In today's class, we are going to be dealing with more and more problems. But before that, we are going to see what the position vector actually means. Okay? We're going to see that. So, take this, update your note. A position vector now. If O is the origin, then the vector OA is called the position vector of A. The vector OA is called the position vector of A. For example, if the position vector of A is 2 vector A minus 3 vector B, you can see on top of this A there is an arrow. It shows that it is a vector. It shows the direction of the vector. It's carrying a direction. So 3B, this B is carrying an arrow too. It is a vector, right? If I do not put this arrow there, it is no longer a vector. And this 2 is a scalar, this 3 is a scalar, or minus 3 is a scalar. Okay. For example, if the position vector of A is 2A minus 3B, then O being the origin, so that's telling you that it's a position vector. Now, I'm positioning it with respect to the point O, the origin O. So, OA now is equal to 2 vector A minus 3 vector B. That's how I can now write A, right? We're going to see more questions with respect to that. So now, I'm going to be using vectors. Using vectors, the following principles should be noted clearly. If two vectors are equal, for instance, this is a vector equal to another vector, M vector A plus N vector B, you see, is equal to P vector A plus Q vector B. They are equal, right? If they are equal, then I can now take the coefficient of this vector A, M, is M. Coefficient of vector A here is M. Is P, sorry. So M and P will be equal. M will be equal to P. If you have this kind of relationship, then M is equal to P, N is equal to Q. Everybody should know that, okay? That is very important up there. Number 2, if the points P, Q, and R are collinear, what is the meaning of collinear? When we say 2 points are collinear, that means they share the same line. They are on the same line. So if 3 lines are collinear points, if 3 points are collinear, it means that they are on the same straight line, all of them. That means they are sharing the same straight line. That is it. Okay, now if 3 points are collinear, then this is the relationship. Vector PQ is equal to vector QR. I'll explain that very soon. Okay, don't worry. Let's just take this example first. This example has to do with the first case here. The first case. Can you see? This example has to do with it. Let's use this to solve this. The first case to solve this. Okay? Given that vector P is equal to 3 vector A minus B and vector Q is equal to 2 vector A minus 3 vector B. Find the numbers X and Y such that XP plus YQ is equal to vector A plus 9 vector B. Vector A plus 9 vector B. Okay? That's what we're going to find. Alright, let's see that quickly. So, that question, I'm going to use this first case to solve it. Alright, solution. All I need to do is to put that relationship. Okay, this one. We have that vector P is equal to 3 vector A minus B, vector B. And this is the vector, right? And then vector Q is equal to 2 vector A minus 3 vector B, like this. So all I need to do, I am going to find the values of X and Y such that this one is equal to this one. So I'm going to look for those values. So I'll now say, now, we have what do we have over there? We have XP x vector p plus y vector q is equal to vector A plus 9 vector B. All I need to do is to substitute P and Q, vectors P and Q in this expression. So we are going to be having x bracket. What is my vector P? My vector P is giving us 3 vector A minus vector B. Close your bracket. Then plus y vector, my vector q is given as this, right? 2 vector A minus 3 vector B. Like this. See? So everything here is equal to this. Vector A plus 9 vector B. Like this. Equal to that. All I need to do again here is to simplify this expression. Let me simplify and put together all those coefficients of A. Okay? Because I have an A here, I have an A here, I have B here, I have B here. Let me collect all of them as terms in themselves. Now, open this bracket. You're going to have 3x vector A. See? Minus, open this, you are going to have x vector B. Plus, open this bracket, you are going to have 2y vector A. Minus, open this bracket, you are going to have 3y vector B. All will be equal to vector A plus 9 vector B. See that? That's it. Now, clearly you can see that all the terms containing A, I can put them together. Let me put them together so that they will rhyme with that kind of expression we have in the first case. Okay? Now we have this and this. This and this. So I'm going to factor out A from these two terms. See these two terms? I'll factor out A from them. So I'm going to have 3x plus 2y vector A. Or let me write it here. Better? 3x plus 2y vector A. See? These two vectors put together. See that? Because I have a vector A here, I have a vector A here. Let me combine them together. So, plus, now, I have vector B here, I have a vector B here. So, since both of them are minus, I'll pull out the minus, I'll pull out the negative. So, I'll have factoring the negative out. I'm going to have minus x bracket, minus bracket x plus 3y, then vector B is here. Look at it carefully. This is what I did. This has a negative, this has a negative. I pulled it out. I factored it out. And then I have plus within the bracket. So my B is factored out here. See that? My B is factored out here. So everything would now be equal to vector A plus 9 vector B. That's it. So from here we can now say that this is the coefficient of vector A here. And this is the coefficient of vector B here. I can easily now say that this coefficient is equal to the coefficient here. Coefficient of B, vector B here is equal to the coefficient of B on the other side. And so we have therefore, what do we have? We have 3x plus 2y is equal to 1. Equation 1. See how simple this is? It is equal to 1 because the coefficient of A here is 1. Then this coefficient of B here would be minus bracket x minus 3y plus 3y is equal to the coefficient of B here is 9. Equation 2. See that? That's it. If I if I like, I can divide 2 by minus here, then this negative should come here, and then I'll have the negative here. See, I can do that, it's okay. Still the same operation. So the negative will now be here with the 9. Okay? Because there is negative here, I can take it to this one over there. Okay? Alright, make sure your note is up to date, please. I can now solve these two expressions. From 1 or from 2, it's easier to solve from 2, right? From 2, you know, x is going to be equal to minus 9 minus 3y. If you make x the subject of the formula from 2, it's going to be equal to minus 9 minus 3y. Put this in 1. Put this in 1. Therefore, 1 becomes 3 bracket minus 9 minus 3y plus 2y is equal to 1, like this. And so when we open the bracket, we're going to have minus 27 minus 9y plus 2y is equal to 1. Okay, minus 9y plus 2y is going to be minus 7y. Minus 7y is equal to, here is going to be 28. If this goes to the other side, minus 27 becomes plus 27 on the other side. 1 plus 27 is 28. So, y is going to be equal to minus 4. That is it. But x is equal to what, somebody? X is equal to minus 9 minus 3y. So we have put this in, alright, no? I'll say put y is equal to minus 4. Therefore, we have x is equal to minus 9 minus 3 bracket minus 4. And so x is equal to minus 9 plus 12, which is equal to 3. So that means that x is equal to 3, y is equal to 4, minus 4. That's my answer, okay? We're going to see another video with more and more problems. But for now, pay attention to this, to the details here. I'm going to test you on it. Thank you.